For those of you just tuning in, my name is Tiffany Conroy, and I work at SoundCloud, which, if you've been paying attention to the news at all, yes, SoundCloud still exists. I do work there. It's going. And I'm going to talk about a feature that we added recently, which I call remote sign-in. To describe it in the most general way I can just think of is I call it a method for signing in to a device that doesn't have a keyboard. I'll explain what this means, but first I'll explain who I am. My name is Tiffany, and I've worked at SoundCloud, as I said, for 6 years in Berlin. We are hiring. I currently work as an engineering manager there. Until recently, however, I was the product manager for our user auth team, and that included our sign-in and sign-up flows. And my final project as the product manager for user authentication was leading a cross-team effort to build a keyboardless sign-in experience when we launched our Xbox app. If you haven't seen the Xbox app, it's really sexy. And signing into it was not in the initial stages. And I found this really interesting, and I think there's a lot of really interesting details, and I'm going to share them with you. So, what do I mean by remote sign-in? As far as I can tell, this type of sign-in method doesn't have an established name. Google calls it a sign-in for TVs and devices. You may have seen it to sign into YouTube on your TV. And it's sometimes called pairing, or it's sometimes called activating. In any case, I'm going to describe exactly what it is. And something else to note is I've written a detailed blog post with exactly this content. So if you've seen exactly that content, spoiler alert, it's that. But the reason I'm mentioning it is you don't have to take notes. There's a lot of details. I mentioned some documentation. And you don't have to take any notes. I'm going to tweet out that link. And I'll show it at the end. So SoundCloud on Xbox, we were developing a SoundCloud for Xbox One app, and something became really obvious during usability testing. We were not even trying to test for this. And what we learned was that signing in with the game controller is not fun. In fact, it's awful. You can kind of imagine. Here you see someone trying to enter a password with a game controller using an on-screen keyboard. You have to navigate to the individual characters. You have to navigate to individual letters and numbers one at a time. Numbers and letters and characters are on different screens. There's 3 different screens. And the more secure your password is, the worse this experience is. And we needed a way for people to sign in to the app some other way, because this was their first impression of the app, and it was awful. We wanted something that was secure and simple and fast. That's what we were aiming for. So I'm going to describe the solution in brief, just sort of conceptually, what is this? So the person opens the app, and they want to sign in to SoundCloud on the Xbox One, so they click sign in. It's the only thing they can do, so they click sign in, and then they see this screen, and it tells them to go get a different device, like their phone or a laptop, and go to soundcloud.com/activate, and then from there, if they're not already signed in, sign in and enter this code that they see. So they go to soundcloud.com/activate on another device, they enter this code, they press enter, boom, over on the Xbox they're signed in. This is the screen you see right after sign in. It's telling you how to navigate your way around the app, and then they close this and they're signed in as their SoundCloud account. They did not do anything on the TV, on the console, they just did it on their phone. So this is what I'm calling remote device sign-in. And we needed to consider that someone might do this with a laptop or a tablet or a mobile phone, and what we really wanted to take advantage of was the fact that they're probably already signed in on the phone or on their laptop or wherever else they're using this. They're probably already signed in there because they probably use SoundCloud on that device. And we didn't want them to have to use the controller. So how does this work in a bit more detail? This is not the full implementation, but it's a bit more detail. So consider a person, they have 2 devices. They have a console, device A. It could be a console, it could be a TV, whatever it is, it doesn't have a keyboard. Maybe it's your watch or a refrigerator, whatever it is. And the other device B is one that's easy to enter text on, like your phone or your laptop. And they want to be signed in on device A, and they have this device B around. So device A asks your service, give me a code. And the service responds with this short code, ABC123. And it displays this code along with the URL that the person has to go to. And then device A starts polling. It checks on the status of this code that it's showing to you. So every few seconds it's polling for this code. So it says, hey, what's the status of ABC123? And your service is like, not activated. And you're like, okay, how about now? And then not activated. How about now? Not activated. So it's doing this like maybe every 5 seconds or something like that, long enough to give the person a chance. And it's polling in the background. Now, in the meantime, this person, they pull their device B from under the sofa cushions, and they go to the browser. They go to the easy-to-read URL. Yes, you could use a QR code. And on this device B, the person might already be signed in to your service. Hopefully they are. If they aren't, they just sign in, or they create an account, and then they're shown this screen. And this is now allowing them to enter the code here. They enter it. Now the phone sends to the service. It says, hey, someone just entered this code. Is it a valid code? Like, is this a correct code? And the server's like, yep, that is a valid code right now. And then the device says, okay, someone with this access token, someone who's signed in with an access token has just confirmed this code. And the server is like, cool, I've got this. I know who that user is. And now I've associated the code with the user. Now let's go back to device A. It's polling. It's like, hey, what's the status of code ABC123? And the server says, it's confirmed. Someone's activated it. And the device says, great. Now take this code and give me an access token for that user. You know who's associated with that code. Give me an access token. And the web server's like, great, here's the access token. And now, by definition, if you have an access token, the person signed in. So this is how this works. We did not invent this. As I mentioned, YouTube on TVs has the same thing. Google Sign-In for TVs and devices has the same thing. And they have a really detailed implementation documented on their website. And you can find that link in the blog post I'm going to post. They have it here. Like I said, it's called Google Sign-In for TVs and devices. And they have a full implementation outlined. You can either copy this implementation or you can use Google Sign-In for this kind of thing instead of implementing it yourself. So one of the key parts of this is using an authenticated session on device B, which is a very fancy way of saying we want to take advantage of the fact that the person is already signed in on their phone or their laptop. Meaning we want them to sign in without having to sign in because they were already signed in, right? So we've got these two devices, the game console or toaster or whatever. And so remote sign-in is when the person doesn't have to enter their password on device A. They might have to enter it on device B, but hopefully not. If they're not, they'll have to sign in. Now, if you're doing this in a web browser, this is surprising to no one, that when you go to a URL on your service, they might already be signed in. This is like not mysterious, right? There's an access token in the session cookies, and the person signed in. If they're not signed in, you make them sign in first, right? No mystery. This is not surprising. On the phone, however, we wanted to use the same web app in a web view in the native app. And so if the person visits SoundCloud.com and they have the app installed, we open up the native app and then we open up the web view. And the way we accomplish this, getting the who's signed in into this web app that we've opened, is we first pass them to a sort of OAuth 2 style callback web address. If this is unfamiliar to you, this is part of OAuth 2's callback mechanism. And so we pass it to this different address first. And we pass in the access token of that user in a so-called fragment, meaning it's following the hash. And this is an important security detail. We put the secrets in a fragment because fragments are not sent to the server, and therefore they don't appear in logs. But the web browser can get access to this, and it can use it for itself. So that's why it's in the hash. If we're doing a GET, we have to put it there. This is the recommended way of passing secrets in a web address. And the other detail is in the query parameters, we pass a display property. Obviously, we are also using responsive CSS to get the proportions nice, but we also wanted to do things like have the ability to make the Android web view look more like our Android app and make the iOS look more like our iOS app. But primarily what we do is we get rid of the header and the footer because the app has its own header and footer. And that's what we do with this property. So then we open up this web view, it passes the information of who the user is, and then it can display the correct user. Cool. You could, of course, put this directly into your native app. What we liked about having just one web app that we used for both was it allowed us to iterate quickly on this new feature, and we could release new versions with perhaps more security features without having to ship our native app again. Yeah? So that's why we chose that. So one major consideration when implementing this that we spent a lot of time thinking about, surprisingly, is choosing the codes. What do they look like? You want them to be easy to read and easy to type. Should they be numbers, letters, a combination? You want them to be short as possible, but you also want to have enough of them that you can give them out to everybody who wants to sign in at the same time. So there's a number of things to consider, and I'll walk you through starting with the most trivial aspect, or maybe not the most obvious, but you'll see. Anyway, so things to consider: sparse usage. Now, for those who are maybe second language English speakers, I wanted to really explain what I mean by sparse. It means a small percentage really spread out. So I visualized it. Here's a sparse usage. If all of these dots were to represent codes, then the X's are the codes in use. It's like spread out. And it might be sort of intuitively obvious that you want to have a sparse usage of your codes. There's some very specific security reasons that I'll go into detail about. But the main one I want to really sort of think about is typos. You want to avoid people accidentally typing the wrong thing. And really trivially, if we can imagine that your code was one number long, you would have 10 codes you could give out at any given time. It's really unlikely someone's going to accidentally think it says 2, but it says 1, right? Like, they're not going to make that kind of typo. But you can only 10 people can sign in at one time. So this is obviously not useful, even though you're preventing typos pretty well, right? No one would do this, but it kind of starts the thinking. So what if your codes were 2 letters long? You would have a possible 676 codes to choose from. Now you have some possibility that someone might make a typo. So they might type the very similar code to one that's issued. So you can't release all the codes at once, even, because you might have these typo issues. You probably can't even release half of them at once. Maybe you can only release 10 of them at one time. And what is at a time anyway, right? Ever? You can only ever give out 676 codes. So this is when you start to think about the implementation details start to get to be interesting. So what if we did 6 digits, 6 numbers? That gives you 1 million codes if you use leading zeros. That's pretty good. That might be enough. You could have them shorter. You could use letters. Then you get 500,000 codes. That's still kind of a lot of codes, right? Sounding pretty good, right? What if we did letters, numbers and letters, right? So once you do this, boom, you got to not use 0 and O, and you can't use 1 and I, because it doesn't even matter if your font is correct. People might see the wrong thing. So right away, you can't use these. That gives you 32 different characters you can use. We chose to use 6. That gives us just over 1 billion codes. Now, if this seems like way more than you need, we'll talk about the security implications later. 1 billion is the right range that you want to be in, even if you're not, SoundCloud. So some things to consider in addition to this. We'll go into the security details later, but some just picking the codes, like don't use special characters, like seems maybe obvious to some people, not to others. Use uppercase for readability, but verify using case and sensitivity because mixed case is just a nightmare for folks. Something I didn't put in these slides, which I wanted to mention, was the question of whether or not people who don't use the Roman alphabet would have a problem with you using Roman characters. And we had some people at SoundCloud who regularly do gaming who don't use, they have a language that doesn't use Roman characters, and their lived experience was everybody has access to these Roman characters who do gaming, so they can do stuff like this. So they can have in-game chatting and they can enter passwords and like it's, so in practice for gaming purposes, they've got those keyboards handy. They know how to enter those codes, but that is something to consider, which is, are the characters you've chosen accessible to everyone that you're targeting? So let's get into the security considerations. Now, in its most basic form, the flow that I described has a number of security problems ranging from mild and unlikely to wildly irresponsible, and I will cover them. So mitigating these security considerations means adding details to your implementation. So risk number 1, accidentally granting device A access to the wrong user. So someone is signed in by who? If you're like me, you have a similar problem liking videos on YouTube. Am I signed in my work account? Am I liking this as my work personality? Am I liking this as my personal account? Am I adding this to my wrong watch later list? Like who signed in, right? You want to know who. You may have the same problem with your real and test Facebook accounts. You may have this problem just with your real, your real and work, your personal and your work Google accounts. I don't know if you've noticed this, but Facebook has this problem in their web view. When you're granting access, they've stopped saying who is signed in. That drives me nuts. So you need to know who signed in, because if you have 2 different users, you might accidentally sign in with the wrong account than the one you intended, right? So, how do you mitigate the risk of accidentally granting access to the wrong user? Well, you show which user is authenticated. You say you're signed in as this user, and you allow them to switch. Or you can display a selection of all the users that are authenticated and let them pick one. Facebook and SoundCloud do A. Google does a kind of combination of A and B, and sometimes just B. But that's how you do it. You say who signed in, and you make it clear. So another risk is accidentally granting access to someone else's device. Now, this one is a little bit harder to explain, but it's essentially the problem that happens when you make a typo. So you have you have 2 codes that are issued at the same time, and they're very similar to each other. Device AN is going to show Nina the code XXN, and device AM is showing Michael code XXM. So Nina goes to her phone, she takes it out, she's typing, completely accidentally she types XXM. Magically, in another location, Michael's device is now authenticated as Nina. Like, Nina made a mistake and doesn't even know it because it's like, hey, you're authenticated. And she looks at her game console and she's not. It's still telling her to sign in. Michael, meanwhile, is like, oh, I'm signed in. Okay, great. Now, he might not even notice that he's been signed in as Nina for a while. And that's not his fault. It's Nina's fault, kind of, but she can't tell that it even happened. So, how can we mitigate the risk of granting access to someone else's device? Well, you have a sparse usage of codes. You have it so unlikely that you know, if Nina enters a code which is very similar to the one she was issued, it's probably just not a valid code. And this is really, you know, one of the only ways you can prevent this from happening is to just have so many codes available that you don't issue similar ones. And like similar by what definition? You just have to have them so spread out that it's unlikely to have these collisions. And another way to do it is you could collect the device information of like device A, and you've seen this if you connect with Bluetooth. It says like, do you want to connect to the device called this thing, right? So you collect the device name, and then you show it during activation. And then the person can say like, oh, did you want to connect to DJ's TV? And then the person can be like, yeah, that is the one that I want to connect to. So they enter the code, and then it confirms, like, is this the one you actually wanted to connect to? And then you say yes. We found specifically that the Xbox One doesn't have this kind of concept of a device name, or at least we didn't have access to it with the permissions we had. So we could only display the type, which isn't that useful because they're all the same type. Anyway, in any case, it would be good to collect some information. So if the device had a name and you could collect it, you would want to show that for this reason. So another risk is that an attacker could use up all possible codes so that no one else can sign in, right? They just take all the codes at once, and when something else tries to get a code, say like to issue one, your service can't find a code available for it. It's all the codes are taken. An attacker does this because they want to ruin your reputation or otherwise destroy your business. Or they're just a jerk. They're just some kid who thinks it's funny, right? So you need to prevent this kind of attack, though, because it's like pretty simple one to do. And in order to prevent something like this, you either have to have so many codes they can't possibly do it, or there are other ways. Like, what are the ways of mitigating this attack of using up all the possible codes? So one of them is you could rate limit the ability to request codes. You would want to set up rate limiting on all the different facets of the request that you can, like what is the IP address? Is there a unique device identifier? You know, is it the same user agent? Like you try and rate limit on both as many specific and broad things as you can to catch people who are trying to screw with you, but also people who are abusing it. The unfortunate thing with attackers is you have to go broad and specific when trying to prevent things, because they'll just find ways around your limits. You're going to need to investigate before you go live, what does a legitimate traffic look like, and then you don't accidentally limit traffic to legitimate people. So the other thing you can do is you can expire your codes, so you can at least reuse them. You don't want to like give them out once and then never use them again, because eventually you're going to use up all your codes, right? You need to recover them. But don't reuse them too soon. For details I'll go into later. But you're going to need a pool of codes that you can safely issue and not need to reissue for like a week is a good range. So here's another risk, and that is that an attacker just guessing codes and trying to use them to get access tokens. They're going to pull for just random codes. They're going to keep asking, and they're hoping to exchange it for an access token. This is typically called a brute force attack. They're just moving through a list. Brute force attack is why you used to have to, you know, after 3 tries of entering your password, it would stop you for a while. It's trying to like slow you down in this brute force attack way. And they're just trying to get access to any account they can. So what they do is they ask your service, like, what is the status of this code? They find one where the server says yes. They try and exchange it for a code. Boom, they have a token for somebody random. This is sort of like the easiest attack to imagine for an attacker. It's also the easiest attack to implement. You just keep slamming it and you tweak it so that it's under your rate limits, and you just keep doing this, right? It's also really easy to protect against. Really easy, but the solution is not so obvious. As an aside, you might wonder why an attacker would want access to random accounts. I'm not going to answer this question, but if it is interesting to you, please ask it at the end or separately. So how do you mitigate the risk of an attacker guessing codes and using them to get access tokens? So you might think, well, what if I just use very, very sparse codes? And the likelihood, if I just have so many codes, the likelihood that they will guess one that's actually currently used and active is going to be really hard. This is how most authentication works, right? You get a long access token that's hard to guess, and that is why it's safe. But the whole point of this is that it's not a long token. It's like, you know, something short, fast, easy to read, types easily, person feels like magic, right? So this doesn't work. You could have rate limit for polling. Now keep in mind they're only going to be polling one thing at a time. It either works or it doesn't. You could do this. They're just going to tune their rates until they're under your rate limits, until you adjust them and find them. You should definitely have rate limiting, but it's not going to save you. And in addition to that, there's a much simpler, totally secure way to do this that solves the problem entirely, and that is polling tokens. And this is when you issue the easy-to-read code to the device A, you also issue a really long, difficult-to-guess polling token. This one I just made up this morning, like doing this. It's going to be really hard to guess. And you issue this polling token to device A when you also issue the easy-to-read code. And then you require this polling token whenever you're asking for the status of the code and whenever you're exchanging the code for an access token. And as long as these things are associated for the duration of the thing, you solve this problem. You have to know this really long code and the short code, and they have to match. Problem solved. Quick aside, Google calls the short code the user code, and they call this polling token the device code. So you can see in this example, the user code is really short, and the device code looks like an access token. It's long and hard to read. There'll be a link to this documentation in the blog post. There is one in the blog post. So another risk is that an attacker is trying to trick people into giving away access to their account. They're trying to there's this whole category of attacks where an attacker is attempting to influence their victim into doing something voluntarily that's not in their best interest. And this is called a social engineering attack. For example, the attacker could take advantage of the fact that your UI design allows user input that they can change that will fool people. And if your UI doesn't help it, so it's easier for me to show you. So in this example, it says, confirm the activation. You recognize your name, that's you. And you recognize that there's a word there. And then you say confirm. Now, this was the original design that our designers came up with, and it did not pass an initial security review. And the reason it didn't pass security review is because the security person just did this. They changed the name of the device to the SoundCloud Premium add-on. And then someone could construct an email that they email out to whoever, and they say, follow this link and enter this special discount code, and then you can get a SoundCloud Premium add-on. And there's nothing about the design that explains to people that that's not what's happening. What they're actually doing is giving away access to their account to someone. So to mitigate the risk of these kinds of trick attacks, what are some of the ways we can do this? Now, the main way to do this is to use text and design elements that make it clear what is happening so people can fully understand what's happening, even in the case where the user is trying to manipulate them. So what does that mean? In our case, we added the text, confirm your device, not just activate. We said sign into SoundCloud on this device. We added the label device in front of the text that the person can enter so that they don't just, like it's clear, like if they put in something different, it doesn't make syntactic sense anymore. And then at the bottom it says, by activating, you allow this device to sign you in. Only activate if you are doing this intentionally. Do not activate if you followed a link someone sent to you. Now, from a design perspective, our designer wouldn't have invented all these UI elements, like it's way more than is necessary to explain the core function of this feature. All of this extra labels is meant to prevent a social engineering attack. It is not necessary to put this stuff for the person to use the function in the ideal state. Anyway, you can go a little bit further with this. You can, when the code is created, you can store the requesting IP or the resolved geography, and then provide a warning. There is still time, I promise. There's still, then if the geography is like wildly different, because it's supposed to be a person in the same room, you can tell them, warning, your current IP address is in a different region than the one your activation code was requested in. Only continue if you're trying to sign into SoundCloud on another device. And then lastly, have short expirations, so that when the person sends out an email saying follow this link and enter this code, that email is really only going to be good for 5 minutes. They would have to act really quickly. So my closing thoughts are using a game controller to enter passwords is not fun, but designing and implementing a new kind of authentication flow is fun. Our team really enjoyed thinking through this problem, and my last bit of advice is involve your security experts early. From the very beginning, we involved the security experts, and we were able to catch things like these social engineering attacks, and making sure that a polling token was part of our original design, and knowing that we were going to have rate limiting was all really useful. So we went from something that was a really painful experience to something that felt like magic. And thanks.